of systems and matrices, right? So that's just to illustrate that it's a useful tool in some more complex situations. Um, okay. I actually went and sat down with Mr. Jones, and he chose your challenge problem at the end of your assignment today. So just wanted to, he was like, this is the hardest one on the whole thing. I was like, sweet. Is it? Trust me, it's going to be super easy after I teach them how to do it. It's not going to be hard because they're going to have a tool that works every time. And that's what I'm interested in the future. So this is I've got 3 hydrogens. I have 1 phosphorus and I have 4 oxygens in the first view try. Okay, here I've got 1 calcium. I've got 4 hydrogens. I have 2 phosphorus and I have 8 oxygens. Okay, so if you got those numbers, fantastic. If you didn't, let's try to examine why that happened. Most likely it's forgetting this outer subscript. Okay, that's number 1 reason you're going to get a crazy answer today is because perhaps you counted wrong in the first place. So what I'm about to do, I really honestly prefer if you just watch me do it right now, and then I'm going to go back over it again. Now, if you just love to write stuff, then be my guest. But there's a lot of conceptual underpinnings that I'm going to explain. Again, the why this works and why it connects to the chemistry and why we set up the model the way we do. And then a little later, I'm going to drop those training wheels, and we're just going to be like, this is the procedure, okay, which will be a lot easier to follow. It'll be tough to follow during this example, and that's normal. It doesn't mean it's hard. All right, so the first thing I want to do is I'm going to kind of make a table that outlines each type of element present and how many atoms of that element are in each compound that we're adding together. And don't forget, on the left-hand side are my reactants, and on the right-hand side are the resultant products, okay? And this is like, I guess this means like the reaction happens. And we interpret that to be an equal sign, right? Because recall the number of things over here has to be equivalent because of that law of conservation. These have to be equal to these. That's why we call it balancing chemical equations. So in this first part right here, I've got 1 iron and 0 chlorines. In this second part, I have no irons and 2 chlorines. And in this part right here, I have 1 iron and 3 chlorines. And I imagine that this is my equal sign, right? So when we're writing an augmented matrix, that's kind of what that represents, okay? So now, when we use reduced row echelon form to solve a system of equations using a matrix, when we put the equations into the matrix, all the variables have to be on the left, right? So let me bring you back to yesterday. If I had x plus y plus z equals 40, and I had y minus 10 equals z, I had to bring this guy over here so all of them are on the left. Do you remember that from yesterday? So I can take the coefficients. All right, that's kind of what's about to happen here. Because as of right now, the variables I will define, the coefficient for the first reactant is A, the coefficient for the second reactant is B, and the coefficient for the product or products, in this case, it would just be C. So that corresponds to the variables here. So actually the equation I have is, 1A plus 0B equals 1C. And this second equation for the chlorines, because we're writing one equation for the irons and one equation for the chlorines. And so that'll be 0A plus 2B equals 3C. And by the example I just showed you, we remember from yesterday, all the variables have to be on the left. So we're going to rewrite them accordingly so that we can use the matrix and reduce row echelon form because it's easy. So this would actually be simplifying. It'd be A minus C equals 0. Because if I subtract 1C from both sides, then drop all my zeros and ones, this will essentially be A minus C equals 0. And this one will be 2B minus 3C equals 0. Is everybody with me of why I'm doing what I'm doing so far? Okay. Remember what I told you, this is going to be a lot. So, and also remember when I'm about to write a matrix, I really would like everything to line up. So that would be A minus C equals 0. And so then I'd have the B's here, 2B minus 3C equals 0. And now it's pretty easy to see what matrix I will write. So let's write it. So this will be 1, this is 0, this is negative 1, this is 0, this is 2, this is negative 3, right? That's my coefficient matrix. So what's the difference between that one and the original one? The last column is negative. So if you imagine this to be your equal sign, if we move these guys on the other side of that, then they basically just become negative, right? That's why the reactants have negative coefficients in the system, okay? This is the why. This is what we do. Yes?
Do we have to do that, or can we just write negative first? Will those always be
You
negative?
may just take this shortcut. All of this, you need to understand it because later in some problems you'll hit something and you won't know how to interpret what you're looking at. Okay. So conceptually it's necessary that I show you these things because otherwise you may get confused later. Okay. So let's do the reduced row echelon form for this matrix. Okay, let's see, what did I end up getting here? I ended up with, 1, 0, 0, 1, and I ended up with negative 1 and negative 3 over 2. So this is my reduced row echelon form. And so in order to solve this, I need to recap and remind myself that this column is A, this column is B, and this column is C. So now let's pull out the solution. So if I pull this out of here, it's going to be 1A, which is really just A, minus 1C, which is really just C, equals 0. Okay, and this second line here would just be, B minus 3 over 2 C equals 0. Because this is C, so this is 1B minus 3 halves C. Still tracking? Okay, where did it fall apart? Right here? So this column is for A. So this is 1A plus 0B minus 1C. And this is 0A's plus 1B minus 3 over 2C. Is that better? So you're seeing how I'm going between the matrix and the system of equations? And also remember what I said. I'm going to drop a lot of these calculations in the next example. I just need you to that's why I said don't write right now, just look. So you're not confused about I'm writing, I'm looking, I'm writing, I'm looking, because there's a lot to take in. And I'm going to explain it again. If you like writing things down, we can do it then. All right, so what am I even doing here? Why am I doing all this? Remember, I ain't getting there if I don't know where I'm going. I'm looking for A, B, and C, right? I'm solving for values of A, B, and C, or X, Y, and Z, whatever you want to call it, doesn't matter. So if I'm looking for values of A, B, and C, at this point it makes sense that I get A by itself. So that's A equals positive C. And B equals positive 3 halves C, right? You tracking? I just add C to both sides. Here I add 3 halves C to both sides. Okay. So recall also from the other day, I told you that when you have a system of equations, if you have 3 variables, you're supposed to have how many equations? If you got 3 variables, you need 3 equations. Do we have 3? No. So we do not have one unique solution to this system. I'm missing an equation that's required to have a unique solution, which is fine. What this creates is what's called a free variable, which is C. And we call it free because we're not given a value for it. All the other variables are in terms of C. A equals C, B equals 3/2 C. But what's C? And it's a free variable because I can choose it to be whatever I want. And the rest of the system will respond to that chosen value of C. Which makes sense because, I mean, I can have different amounts of, these elements, right? I can have a lot of iron and chlorine or a little bit of iron and chlorine. Is that accurate? Is there one way to combine iron and chlorine? No. You can just add more of one or the other to create more reactants, right? Or create more products. So when we have what's called a free variable, we can choose what it is. And I'm going to choose intelligently based on the context of my situation. Can I have 3/2 of a compound?
No.
I can only have whole numbers, right? So what intelligent value of C could I choose that would eliminate this fraction? How about 2? 1/2 would make the denominator bigger, but it's the right idea, okay? Because let's go plug in C here. So A equals C, which is 2. B equals, 3/2 times 2, which is actually what?
3.
Yeah. You put that in your calculator. And so we said C equals 2 already. Okay. So now instead of A, B, and C, I've just got 2, 3, 2, and now it's balanced. Could you have chosen a different number for C? Yeah, you just scale it up. It just means you got more of it. As long as it's a whole number, it doesn't matter. We can double it by choosing 4, we can triple it by choosing 6. Whatever eliminate your end game is you don't need to have those denominators because you can't have fractional compounds and molecules. So, all right, so this is the long version. Now I will show you the short version, okay? Remember I told you, I warned you. And then I'll go back to this and kind of like piece together what's going on. All right, so again, first thing we want to do is we want to make a list or a matrix with what elements are involved. So I've got C's, H's, and O's. And then I'm going to make a list. I have 2 carbon, 6 hydrogen, and 0 oxygen. In this part, in this compound, in the reactants, I have 2 oxygen, 0 hydrogen, and 0 carbon. Here I have 0 carbon. Here I have 0 carbons, 2 hydrogens, 1 oxygen, and finally I have 1 carbon, 2 oxygens, and 0 hydrogens. All right. Remember I said this was my equal sign, so if I'm moving all the variables to the left, then everything on the product side becomes negative. Boop, boop. Do you remember why those become negative? So we have to move them to the other side before we use the matrix. Remember, this is like your equal sign. Oh man, let's see. So this is like your equal sign. We got to move them over to the left, so they're going to become negative. We can't use the reduced row echelon form without having all the variables on the left. Okay, that's why. All right, so put that in your matrix calculator and hit RREF. You want your reduced row echelon form? And I'll write up here what I got.
Will we have to use any of the other ones to figure it out, or can we just always use the other one?
You can just use this. Like I said, I had to show you the why, so you don't get lost when you're doing the how, right? So this would be 0, 1, 0. This would be 0, 0, 1. -7. Or make sure, like, put it in there and make sure you're looking at it so that when it's time for me to explain what's going on, we're not lost. And then let's recall that, these are this is A, this is B, this is C. And so what do you think that last column is going to be? If this is A, B, C, what's this one? D. All right, and once we got that, now I'm going to write, A equals 1/2 D. B equals 7/4 D. C equals 3/2 D. And now D is whatever I want. D is my free variable. And how I got these is just by recalling that this column is A, so that's 1A, 0A, 0A. These are all B's. These are all C's. And these are all D's. Why did I turn them positive right here?
Because you added them to the other side.
Yeah, I just moved them back to the other side and solved for A, B, and C. All right, so what's an intelligent value for D here? What's gonna be the lowest number that will eliminate all the denominators? 2 is not gonna get rid of this one.
Pull it for.
Oh, sorry. I was thinking 2 and right 4 and backwards, so there we go. All right, cool. Yeah, 2 is not gonna eliminate that. Okay, so now we go back and plug in 4 for D. Because D we said is 4, so go plug in D everywhere, and what you're gonna get is, okay, let me move it over. I don't think we're ready for just to see me do it yet. So this will really be 1/2 times 4. This one will be 7/4 times 4 because D is 4. I'm just going back and plugging in my chosen value of D. 3/2 times 4. Okay, so A is 2, B is 7, C is what, 6? Okay, cool, and D is 4, so there they are.
Wait, where did the negatives go?
So this is
Whatever
2.
negative
7,
You added a negative.
6,
one.
4. Yep. I wasn't even where you said yeah. I was just trying to finish my thought. All right, yeah. So 2, 7, 6, 4. Now it's balanced. That's it. But conceptually, I needed you to understand how, why we had to change them to negative and then why we change them back. Also, later, sometimes writing it, and also, if I had just told you, just multiply everything by 4, you would have been like, but why? Like, how can we just do that? Now we can see, well, there's this variable D that we can change based on the context. And I just choose a smart value of it, right? The lowest number that will eliminate all the denominators because it can't have fractional values. This is a tool. I hit nails with a hammer, like I use the appropriate number for the job, right? Like I'm not gonna drive nails with a screwdriver, so I'm not gonna use numbers that don't make sense. That's it. This is just a tool. All right, let's do another one. All right, so again, the first thing you want to do is you want to examine and write down, kind of the list of the elements involved. So you've got iron and hydrogen and sulfur and oxygen. And then you want to go term by term and just, create your matrix for how much of each element is in each term. So this one just has an iron and nothing else. This one has 2 hydrogens, 1 sulfur, and 4 oxygens, and no irons. So we'll put a 0 there. This one has 2 irons, no hydrogens. How many sulfurs? 3. How many oxygens? 12? Yeah. Okay, and then here we have no irons. 2 hydrogens, 0 sulfur, and 0 oxygen. And then reduce row echelon that thing. What step did I forget? I did not make the negative. Don't let that tear you to pieces. Sometimes it will not affect it, and sometimes it will. Everything that is on the other side has to change signs. Yay! All right, so we're gonna reduce row echelon R, R, E, F. And then we're gonna get, the matrix. And so you'll have, 1, 0, 0, then you'll have 0, 1, 0, then you'll have 0, 0, 1. And then you'll end up with 0, 0. Okay, so this will be, let me make sure I'm looking at my right example here. I don't want to mess it up. So this will be negative. I'm about to chuck this thing through the wall. Just like a frisbee. Like the rage burning inside of me. Y'all can't even see it. Let's see, -1. -1 and -1/3. Y'all confirm that this is what you're getting if you're plugging in that calculator. Okay, good. So what I mean when I say that the Y is also important is because when you see that row of zeros at the bottom, you might kind of be like, I don't know what that means. But if you return back to the understanding that these are A, these are B, these are C, these are D, and then you just go row by row, you'll write A equals 2/3 D. B equals +1 D. Well, I'll scroll up so you can see. 1 D. C equals 1/3 D. And then exactly like we expect, D is free. D is whatever. So what's a smart value to pick there? 3. So, you plug D back in, and here we'll have 2, here we'll have 3, here we'll have 1, and so your coefficients are 2, 3, 1, and 3. But that extra row of zeros down there will throw you if you don't do this part. Or it might throw you, maybe it won't. If you have 2 rows of zeros at the bottom, which can also happen, it might mess you up. If you don't know to go line by line, yes ma'am.
Why wouldn't 0 be D?
Because of exactly what I'm showing you here. Because this is 1A, this is 0B, this is 0C, and this is 2/3 D. This is A, and all this is just zeros. We're going to get what we need up here. C, D, well, you're going to have 0A plus 0B plus 0C equals 0D. Of course it does. But this provides no information. All that is 0 equals 0, which is a true statement. So it doesn't mess us up. It doesn't say 1 equals 0, which would be catastrophic. We would say there's no solution. Here instead, we have what we need. So we just disregard the row of zeros, but that is an indicator immediately that you have that free variable. Did you see what I mean there? Of course, 0 equals 0 in the end.
What if there was something at the end when we make it D and then?
Yes.
Okay.
Well, no, what would happen if you had a 1 right here or a 1 right here for D is you would have to D, there would be it'd be locked up because that'd be 0D equals 0. That's still, that'd be 1D equals 0, and so it would be 0. So it's not
You're still
gonna
at the time for 3.
Yeah, you still have to do this part until you get good enough to be able to look at that. And sometimes it will hurt your head because you're trying to go down instead of sideways.
Why would A be with 2/3 if A is the column?
Because the equation you pulled out of here is 1A minus 2/3 D equals 0. And then you solve for A by adding 2/3 D to both sides. So this goes away and you're left with A equals 2/3 D. So what I'm doing is I'm writing this equation.
Oh,
Okay. All right, so that's there you go. Coefficients 2, 3, 1, 3. And that's it. You can balance any like that. 2, 3, 1, 3. Want to do one more? Why don't you all try to do number 4 and then I'll do it with you. And then we'll see if we do it and then I'll give you your assignment and then towards the end. I had 15 problems on your assignment, but I'm only gonna make you do 8. Yeah. But we're not there yet. Let's do this one together before I set you off on your own. Yeah. Because that's not using the matrices. You can do that in Mr. Jones' class. Not in your.
That's tough.
Yeah. Because the challenge, remember I told you, he chose the challenge problem. So if you hit one like we intentionally chose one that you couldn't do in your head. He knew most of y'all would be able to like look at it and see, but I want you to learn to use this key. Oh, thank you so much. Is that it? Yes. We might be ready to put these in boxes today. I gotta do it Monday. Well, never mind. I got somebody bringing some back to me. Thank you. Yeah, you see how you're gonna get I think you're gonna get that double row of zeros at the bottom on this one. And like I said, if you just go through and write the equations, or just, I don't care if you even write the equations. Really, all I'll ask to see is the original matrix in the reduced row echelon form, and then you can just tell me the coefficients, but I need to at least see that. This will be, like boron, chlorine, lithium, sulfur, oxygen. I know y'all can count. So what you should end up with here. Your last row. So your last row should look like this, and you should interpret that as A equals 1/3, B equals 1/2, D, C equals 1/6, D, and D is 3. So how many rows, or how many columns? 4? Yeah, that's 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. So you might think, oh, I've got 2 free variables. No, you do not. This is A, this is B, this is C, and this is D. So 1A equals.
So what's the last one? For the last 2?
It's just because you had 5 different elements, but only 4 variables, right? That's why you got 2.
No E.
No, because look, this is what you're solving for: A, B, C, D. There is no E because there are 2 reactants and 2 products, and those are the coefficients you're solving for. So I'm going to pick 6 for D. So A is 2, B is 3. This is 1. And there you go. 2, 3.
Just like to try to do it.
So look, this is the problem Mr. Jones chose. That one you cannot do. The coefficients are in like the, I think like in the hundreds. So
Do we get extra credit if we solve it and bring it in?
if you solve it and show it to me, I will give you extra credit.
I'm gonna take it.
This one right here. Oh no, I'm gonna give you a paper.
I'll take.
I'm gonna give you a paper. You're gonna. So I'm about to give you a paper, and your job.
I'll take
I was
extra
so
credit and
confused.
like
I was like,
$12.
did we do that as an example?
What?
I was like, did we do that as an example? I was looking at FU,
Oh.
I was like,
This one. I did it this morning. We're doing it. It's so nice. Okay, so that's example 4. You're gonna do 1 through 8 on this paper, and the challenge is extra credit. But I've got to see the matrices. Okay, don't just bring me coefficients. I got to see at least the original matrix and the reduced row echelon to give you credit. Okay. So here it comes, and then probably in about 15 minutes, I'm going to talk to you about closing up your projects.
oh wait, this time was the homework if we don't finish?
Yeah, you'll bring it Monday.
Oh, okay.
You don't have to finish. You can just bring it with you on Monday.
Oh. Look,
I'll
how
take.
many B's are there?
So,
How many are there? 2. So you have to multiply by 2. Honestly, B. Or B 2. Oh, you do.
And you could probably.
it's counting.
It's ridiculous.
Like I said, it started out feeling awful. Yeah. One through 8, and the last one was a bonus, but I need to see your matrices.
That's true. Literally every single junior in the class is already done. In history or physical science.
Buddy,
it's
all
already
gotta
done.
Right.
It's easy. So, what?
It's lovely, right?
Oh, you can check yourself.
Yeah, that's true.
And that's why I made the B's easy, so you can like,
You kind of know. He's not first one, yeah.
Why? He said he thought it was a great idea.
I have, no, I have the next one.
And you're like, yeah, but it's useful, so.
We did this last school, but we can't do this in class. We can't have those confused out.
Yeah.
I can literally do this. I can literally just talk about
Are you
it.
allowed to have a driving calculator?
Probably, but none of us have that in stats. Only like six.
Well, when you go to college and you have to have a science,
Oh, happy reward.
Yeah. The last one did not look
So
like.
much.
oh, no, it's not bad. Look, that's my work on it.
Yeah. I'm sure you can do it in your head.
Yeah.
Coefficients are like 355, 97, 3. They're pretty good.
You do all of the
Not just 8, just the first 8, and you don't even have to do this. But you should do them with the matrices. All I need to see is the original matrix and the reduced row echelon.
Like the little.
And then from there, you can pull it straight out of there, but I don't need to see
I'm
the
going
one.
to figure these out first and then I will.
That's fine, that's fine, yeah, he told me, he's like, most of your students that have taken chemistry.
Were you good at
It's
chemistry?
true.
I'll give you a chemistry teacher.
Really?
That would be
So, are you
fun.
good at the math work in chemistry?
I've never learned to apply it, but it really would. What math part? Like the stoichiometry?
It's not that, like, I don't know, it's just, that's really learning right now, man.
What?
I don't even know.
We're still doing that.
Oh, yes. Not like
Yeah,
this,
it's
like,
too
it's
much.
just like
Oh,
a lot of
after-
stuff.
We're
I
doing,
haven't taken chemistry since my first 2 years in college, which was 18 and 19.
we're still doing geometry, we're.
Yeah.
So all of that is
I suck
gone.
I suck
If you would like the challenge is optional, but just the first 8 problems. I always make more problems than I need, because I didn't know how fast we would be on this, and how much time we would have.
Ow.
Just 1 through 8, and then the challenge is extra credit. So you will get 1 more extra credit for the 1 through 8.
Oh, that's it.
So it turns negative a lot. So that's all we have to show, and then like the little fractions, and that's it.
Yeah, show me the reduced row echelon and then write your coefficients. Show me the reduced row
The little
echelon.
fractions, where like the A equals.
Mhm.
Okay.
But if I ask you a question, so these, like, you'll have to show it to me. But what if, like, on the test, if I'm like, what is the value of the free variable when you balance this reaction using matrices? What is the value of the free variable? I would need you to be able to tell me that.
Isn't it free variable not empty?
Yeah, the one that repeats itself, right? So
So it's the rating system of the college budget, right?
yes, so
See this.
oh nice, yes. Okay, so I'm going to tell you what to do from here. Okay. And so then at the end, you have 7 more minutes. I'm going to tell you you're going to have to create one more matrix, and we're going to figure out together what that needs to be. And then you will perform some sort of operation, then you'll do your write-up. It's not super involved, but we've been doing it bit by bit, right? So it's not overwhelming. I'm giving a test next block. It's the greatest. I'm so excited because my week is over. Huh? I don't know. Well, I need to, here's the thing. It's important. So I've got to cross-reference my list and do a count and make sure everybody's name is on there. So we're not going to pack envelopes today, probably, just because I don't have all the papers back. So like some of the papers are not back yet. I told everybody deadline Monday, and I still got a few that are out there still. That's fine. Yeah, because they do that, but they're packed over here, so we should be good now. And then, but the plan is to pack as soon as I get a count on them. I'll throw them in there. But the packing is easier than the folding. Yeah. Oh man, y'all are so lucky because the first time I taught it this morning, it was the first time I'd ever taught this lesson because I just made it. It did not go as smoothly as this did. So y'all always get the best of everything because I've already used my first block as test dummies. Bless their hearts.
Because it's not working. And then I'll go back and do the work.
Oh, you're fine. Yeah. Assembly line it.
Oh, internet never works in here.